Hello students, welcome back to this new session on mathematics. Here I am continuing the same module. Previously, in all my previous sessions, we have learned Laplace transforms of various functions, right from your standard functions to the periodic functions, and the Laplace transform of unit step function also we have recently seen. Now, using all those Laplace transforms of all those functions, we will now go through what is inverse Laplace transform. So I hope you have understood it. Once you know the Laplace transform, easily you can go to inverse Laplace transform. Okay. So here I will just give you a small introduction for this, then we'll go on with the problems. Okay. Now see here, if the Laplace transform of f of t, given any function f of t, you all know it is to be f bar of s. So in basic introduction of Laplace transform also I have given this, and here also I will just give you a small idea. So if Laplace transform of f of t is equal to f bar of s, then what should be your f of t? Obviously it becomes L inverse of f bar of s. Becomes L inverse of f bar of s. Okay. So for example, if you, I'll just give you an example here. Say for example 1. If you know that the Laplace transform of 1 is 1 by s, you all know that the Laplace transform of 1 is 1 by s. So if I ask you the reverse way, that is, what is L inverse of 1 by s? So you all will say definitely 1. Similarly, just consider this one. What is the Laplace transform of e to the power at? You know, you have derived this. It is 1 divided by s minus a. So eventually, if I ask you the inverse Laplace transform of 1 divided by s minus a, you all will say e to the power at. That is, inverse Laplace transform of 1 divided by s minus a becomes e to the power at. Similarly, if I just keep on moving, I know that the Laplace transform of sine at, you will have derived this. It is a divided by s square plus a square. So I want inverse Laplace transform of 1 divided by s square plus a square. So what you will have? So that a is missing, you can write 1 divided by a sine of at. Is it? Similarly, we can move on to few more derivations which we have learnt already, Laplace transform derivations. The Laplace transform of cos at, you all know it is s divided by s square plus a square. So you can similarly write what is inverse Laplace transform of s divided by s square plus a square, which is definitely cos at. Okay, similarly I'll just move on to one more formula. You all know the Laplace transform of cos hyperbolic at. So it is s divided by s square minus a square. I have repeatedly said this before. Whenever it is normal trigonometric, you have a denominator positive sign in between s square and a square. Whenever it is hyperbolic, you will have a negative sign between s square and a square in the denominator. So this should be understood. So it is s square minus a square. You can easily write cos hyperbolic at. Similarly, you have one more formula. So I just don't want to even skip that. Let us write that. It is a divided by, that is Laplace transform of sine hyperbolic at, a divided by s square minus a square. Eventually I can write the inverse Laplace transform of s square minus a square as 1 by a sine hyperbolic at. Had it been a over here, I would have just simply written sine hyperbolic at. Okay, I hope this is clear to you. Then another two important formulas I need to mention to you all. What is the Laplace transform of t raised to n? You all have learned this. It is n factorial over s to the power n plus 1, provided n is equal to some natural number. Okay, if n is taking some natural values, then you can easily write the Laplace transform of t raised to n to be n factorial over s to the power n plus 1. Now I want the same thing. If n is a natural number and you have a factorial type or some number, a positive number there, a natural number there, then you can easily have inverse Laplace transform of 1 divided by s to the power n plus 1. If I want, I can easily write it as t raised to n over n factorial, provided n is taking the natural values, natural number values. Last one, I just want to conclude it here itself. What should be the Laplace transform of t raised to n when n is some real number, but it should be greater than minus 1. Okay, I'll say you have one more formula. I won't say this now in itself. I'll just make it clear to you. So if you have one more formula you all know very well. It is gamma of n plus 1 divided by s to the power n plus 1. You see that? So what should be the inverse Laplace transform of 1 divided by s to the power n plus 1? Here n is not a natural number, it is a real number. In that case, how will you write inverse Laplace transform of 1 divided by s to the power n plus 1? You can easily write it as t to the power n over gamma of n plus 1, as you can see. But there is one condition over here. The denominator should not turn to 0, because if it turns to 0, you know that gamma of 0 is not defined. So we have to take n to be greater than minus 1. This condition is must for this last formula. Okay, these are all the inverse Laplace transforms that you need to remember. We'll be working with some problems on this. Just pay attention, all of you. Now see here, students, all of you take a pen and a paper and start working with the problems. See here, we have to find the inverse Laplace transform of the problem 1, s plus 2 divided by s square plus 36 plus 4s minus 1 divided by s square plus 25. It's very simple and very easy. The solution goes as, see here, first of all, let us take the given thing as it is. It is s plus 2 divided by s square plus 36 plus 4s minus 1 over s square plus 25. Okay, let us separate all the terms so that we can take the inverse Laplace transform easily, because yes, see here, you can write it as s divided by s square plus 36 plus 2 divided by s square plus 36 plus 4s divided by s square plus 25. Finally, plus into minus, it's minus 1 divided by s square plus 25. Now you'll have separated all the terms. Okay, now I should give one more important point here. So I'll just write it in a corner. Suppose you have the inverse Laplace transform of c1 into f1 of t, I will take f1 bar of s plus or minus c2 into f2 bar of s if you want to take. Okay, it will be always equal to c1 inverse Laplace transform of f1 bar of s plus or minus c2 inverse Laplace transform of f2 bar of s. So it goes for any number of functions. That means inverse Laplace transform satisfies the linearity property. So based on that, if I want to take the inverse Laplace transform of this, I just have to take in the inverse Laplace transform of these individual terms. Because of this linearity property, I can easily go for it. So inverse Laplace transform of s plus 2 divided by s square plus 36 plus 4s minus 1 divided by s square plus 25. You can write it as L inverse of the first term, that is s divided by s square plus 36 plus, because 2 is constant, write it outside, L inverse of 1 divided by s square plus 36 plus, again 4 is constant, write it outside, L inverse of s divided by s square plus 25 minus L inverse of 1 divided by s square plus 25. This is what you get. Now just take the inverse Laplace transform of individual terms. Now you can see, just verify your set of formulas I have given to you in just the previous part of this session. You will find out what is inverse Laplace transform of this. There is s in the numerator and it is s square plus 36 there. So you can write this as s divided by s square plus 6 square, is it not? So it means what? It is nothing but the inverse Laplace transform for this. You can write it as cos 60. Just refer to your formulas. How I have written cos 60 you will come to know. Plus 2 as it is, which is constant, and there is no s in the numerator and positive sign in the denominator between s square and a square. Same as in the previous case, it is 1 divided by s square plus 6 square you can write in place of 36, and this is nothing but 1 divided by a, which is 1 divided by 6 sine 60 plus 4 as it is. Now inverse Laplace transform of this, I can easily write it as cos 5t minus 1 by 5, inverse Laplace transform of this is sine 5t. We can further simplify this. It is cos 60 plus 1 by 3 sine 60 plus 4 cos 5t minus 1 by 5 sine 5t. This is the solution. Okay, we'll come up with one more problem. Now here you have got one more problem. Find the inverse Laplace transform of the second one. 2s minus 5 divided by s square, 4s square plus 25 plus 8 minus 6s divided by 16s square plus 9. Again same kind here. Same steps, everything is same. Only thing is that in denominator you need to take care about it, because the denominator, it does not have the coefficient for s square as 1, not unity. You have 4 and 16. So one small step you have to do here to remove that 4 from the first term and that 16 from the next denominator term. Okay, so it's very simple. First take down the given thing. It is 2s minus 5 divided by 4s square plus 25 plus 8 minus 6s divided by 16s square plus 9. All you need to do is, like in the previous case, separate all the terms so that you can write first one as 2s divided by the same denominator, okay, minus 5 divided by the same denominator, s square plus 25, 4s square minus plus 25 plus 8 divided by 16s square plus 9 minus into plus, it will be minus 6s divided by 16s square plus 9. Okay. Now as I told you, from the first term you are going to take that 4 common. So you will get 2s divided by 4 you have to take common, so that you can write s square plus 25 by 4 over here. I hope this step is clear to everyone. Sorry, it's minus here. Minus 5 divided by, again take 4 common here, s square plus 25 by 4 plus 8 divided by, you take 16 common because here the coefficient for s square is 16, 9 divided by 16 minus 6s divided by, you take again 16 common, you will have s square plus 9 by 16. This is what you get. Now further you can simplify this. Okay. Okay. Now this will be equal to s divided by 2 times, you can write it as s square plus 5 by 2 whole square, complete the bracket, minus 5 by 4 constant, 1 divided by s square plus 5 by 2 whole square. Okay. Plus again half constant outside, you will have 1 divided by s square plus 3 by 4 whole square. I can write it like this. Similarly the last term, minus 3 by 8 s divided by s square plus 3 by 4 whole square. Complete the bracket, all of you. Now we have to take L inverse on both the sides. We have simplified it enough. So let us take L inverse on both the sides. That is L inverse of 2s minus 5 plus divided by 4s square plus 25 plus 8 minus 6s divided by 16s square plus 9, L inverse of it. It should be equal to L inverse of each of these terms, is it not? So it will be half constant because it is 1 by 2 here. L inverse of s divided by s square plus 5 by 2 whole square you have to take. Complete this. Minus 5 by 4 is constant, keep it aside. L inverse of this term, so it is 1 divided by s square plus 5 by 2 whole square. Plus again half constant, keep it aside. L inverse of 1 divided by s square plus 3 by 4 whole square. Minus 3 by 8, last term, I am writing it here, please check out. L inverse of s divided by s square plus 3 by 4 whole square. Yes, I hope it is seen there. See, I am taking L inverse to each of these terms I have written in the simplified form. Now L inverse of this complete term will be half its constant, L inverse of this thing, minus 5 by 4 constant L inverse of this thing, because wherever you have S, that should be kept inside the L inverse. The remaining constants will be outside, as I have given in the linearity property just before we were discussing, okay, in my previous problem. Plus half L inverse of this term, minus 3 by 8 L inverse of the last term. I hope it is seen there. Yes, there. Okay, that same thing I have written it here. Now we'll take directly apply the formula and try to write the values. So I hope this is clearly cos of 5 by 2t, is it not? L inverse of S divided by S square plus 5 divided by 2 whole square will be nothing but cos 5 by 2t, minus 5 by 4 constant into, there is no S in the numerator, but you have to take the reciprocal of this. So it will be what? 2 by 5 sine, because you write 1 by A into sine 80. Okay, for such a thing you write 1 by A sine 80 you write. The value for A is 5 by 2. 1 by A becomes what? 2 by 5. Is it not? Sine of 5 by 2t plus half. Here the value for A is 3 by 4. So it is 4 by 3 going to be. 1 by 8 it becomes 4 by 3. Sine 3 by 4t minus 3 by 8. I hope it is seen. Yes, see once again. The inverse Laplace transform of this, you can write it like this. Minus 5 by 4, L inverse of this, you can write it like this. Plus 1 by 2, L inverse of this, you can write it like this. I have already explained it. Maybe it was not seen on your screen, but now just see here. It's clearly seen. Minus 3 by 8, L inverse of this is nothing but cos of 3 by 4t, because it is S divided by S square plus 3 by 4 square. Okay, so if you want, you can further simplify this. It is half cos 5 by 2t. I hope it is seen. It is minus half sine 5 by 2t. Okay, plus 2 by 3 sine 3 by 4t minus 3 by 8 cos 3 by 4t. So this gives you the complete solution for this problem. Okay, continue in my next session with some more interesting problems. Thank you.